Finishing off with where we left off from last time, we had lesson 12.3. We were in the middle of finishing this problem with the integral test, and we were investigating summation of x all over e to the x. And what's happening is we're investigating that integral. We showed that our function, if we let f of x equal x all over e to the x, we showed that it was positive, it was continuous and decreasing. So now we're doing this improper integral. You can see we left off when you are applying the limit, you'll have negative infinity and e to the negative infinity. If you look up here at the top right part of the screen here, you can see e to the negative infinity would go to 0. So, we're in this power struggle, if you would. This negative t, e to the negative t. You have something very large in a negative direction multiplied to something very small. Not actually 0, but close to 0. So we're going to have to investigate what's happening there. The rest of the integral works out rather nicely, but look, as we look at what's happening as t approaches infinity of negative t e to the negative t, L'Hopital's rule would come into mind. That's one of the indeterminate forms that we're able to work with. So we need a fraction. To be able to use L'Hopital's rule, we'd like to see 0 over 0 or infinity over infinity. The numerator now, negative t, as t goes to infinity, would be negative infinity. The denominator, e to the infinity, look at the graph I circled, you can see it just launching off. Even though we have different signs here, we can use L'Hopital's rule. L'Hopital's rule would tell us that we take the derivative of the top, we'll get, negative 1 with respect to t. Down below we have e to the t, and e to the t is going to infinity. Negative 1 over infinity would be approaching 0. So both parts of this limit down here with the t variable are arriving at 0. We already plugged in a 1. We saw negative 1 e to the negative 1 minus 1 minus e to the negative 1. That's negative 2 e to the negative 1, but then a negative out in front makes it positive. You could say this is really 2 over e. So our integral converges. It converges to 2 over e. Therefore, what we can say is this series right here, n all over e to the n, converges by the integral test. It's very important to note that we cannot say that the series converges to 2 over e. The improper integral converges to 2 over e. That does not mean in any way that the series would converge to that. Almost done. The p series. The p series right now, if you have the summation of 1 over n to the p, where p could be all different types of positive real numbers, you can see what would happen is n equals 1. You'd have 1 over 1 to the p. That's just a 1. Plug in a 2, you get 1 over 2 to the p. Plug in a 3, you get 1 over 3 to the p. And, of course, you'd have this expansion. A wonderful, wonderful theorem here. I wrote delightful, in fact. You can take it as a statement of fact that the p series from 1 to infinity of 1 over n to the p converges if p is greater than 1, diverges if p is less than or equal to 1. You could actually prove that with the integral test. But that being said, take a look at 3a. You have a p series, 1 over n squared. P is 2, and 2 is bigger than 1. This converges. You move over to the next problem. This is really the summation of 1 over n to the 1/2. Your power is 1/2. 1/2 is less than 1. You diverge. It diverges. And we're almost done. We just have one final problem to take a look at. Real quickly, 1 over n to the 3/2. If you have a power of 3/2, that of course is bigger than 1. Therefore, this series converges. hardly any work to do. You just have to observe what the power is for your P series. It's very important to note that if you have a constant either on the top or on the bottom, remember constants can be factored out, and then you could effectively say that you have a P series of 1 over n to the third here. This series would converge because your power is bigger than 1. Please be very careful. I think you're going to see a problem like this on your homework. You might have something like 1 over n squared plus 4. Students very often want to call that a P series. It is not. If you have an addition or a subtraction of a term next to n raised to a power, you cannot call that a P series. Instead, when you get to this problem on your homework, think about using the integral test, and I hope you're recognizing a form of inverse tangent. Well, best of luck to you.